what I'm going to be discussing with you is associative database technology. And what we're talking about is simply one implementation of it. There are many, many varieties of associative technology. We simply have one form of implementation, and we're developing a second and even a third. Now, moving forward, what I'm going to be demonstrating to you is a number of advantages, both technical, financial, security, privacy, that come into play when discussing and using associative concepts as opposed to the existing paradigm that we have now. All right. That being said, the areas that we're reviewing are association concepts. What is data? What is information? Books and manuscripts, essentially essential ancient indexes, data centers, and green data. We hear all the time, the last one is particularly interesting, and I think you'll find that the world is, it's quite easy to fix the energy issue, simply be using data. That being said, we'll start off with the fact that in global IT spending in 2016 equated to $3.41 trillion. Okay? That's an enormous amount of money. That being said, present day, imagine $3.41 trillion around the world. This is what they spend on IT. And that doesn't count the data centers. In order to understand associative technology, you have to understand what the difference is between data and information. Today, we're sold this equation as being one and the same. They're not. They're completely different. All right? Data has essentially a set of symbols, and we historically as a species do not have data. All right? What we have is essentially an oral tradition going back 10,000 years. That oral tradition was at some point created using words. No language on earth, regardless of culture, has more than 1 million words. None. When you consider that, these are essentially symbols. Those symbols today are represented by the ANSI code, 256 characters, and Unicode to represent all the languages of the world, which are essentially 1 million characters. All right? Moving ahead, the numeric system basically only has 10 characters as well. Now, when you consider this in the sum, these are your data points. That is the only data that we have. We don't have any more. The entire storage requirement is only 18 megabytes. Now, this is completely in contradiction to what the world and the IT world will tell you, and there's a good reason for that, and I will explain it as we move forward. But realistically, that's the data points that exist on this planet, about 18 megabytes. When you consider that can be stored on a piece of silicon the size of your pinky, a lot of questions begin to arise. What is information? Now, information is basically the transfer of knowledge. In our history as a species, we've gone from nothing to recording our knowledge either on stone, on clay tablets, on books, papyrus, leather, metal, paper, tape, magnet disc, whatever medium we could find. And that was for the purpose of recording our knowledge, our experience as a species. The purpose for this was to transfer that knowledge in either training or teaching to the next generation. And of course, the next generation would then use that knowledge to build and create new knowledge or add to the existing base of knowledge. Now, what was the purpose? The purpose was to use that knowledge to further advance the civilization, whatever civilization that happened to be, in all areas, whether it's research, business, government, medical. Now, the oldest form of what I call knowledge management, of course, are books. Books or manuscripts or stone tablets, whatever you wish. And they all have one thing in common. They are essentially ancient computers. manual computers. All right, they are constructed as such. But when you look at the fact that the Bible itself has 2,000 pages, War and Peace has some 1,200 pages, Black's Law 2,000, Moby Dick, Lord of the Rings, and they're all divided up exactly the same way. Book, your data dictionary. Chapter, the index. Paragraph is an index of the sentences within it. So essentially, it's a data structure. Now, the fun part about this is that the unique words in all 5 volumes, or any 5 volumes that you should pick, is around 98.4%. Which means, in layman's terms, I can take all the words of the Bible and write War and Peace. I can take all the words of War and Peace and write Black's Law Dictionary. I can take Moby Dick out of Black's Law Dictionary simply by rearranging the words. Okay? And the vice versa. I can create the Bible out of War and Peace because the data elements are the same. And that's a very important thing. Now, why are we in this situation that we are in this year and in the last few decades? This is Dr. Edgar F. Codd. He is arguably one of the most brilliant human beings that existed in the late 60s, early 70s. Our world today exists because of him. He created, or he defined, and as you can see, the relational model is widely recognized as one of the great technical achievements of the 20th century. And it is, for a lot of reasons. Everyone today that's in business and technology owes their existence to him. A revolution is the way databases were perceived. Indeed, it transformed the entire database field, which previously consisted of little more than a collection of ad hoc products, proposals, techniques into a respectable form. Something that can be defined mathematically is really what it came down to. More specifically, it provided a theoretical framework which, in a variety of important database problems, could be attacked in a scientific manner. Now, this is critical. What this gentleman has done is he essentially defined mathematically levels of efficiency in managing data. Okay? That is something that many people have completely forgotten in our field. Nobody pays attention to his work anymore. They assume that it stopped at a certain point and the rest doesn't matter. As a consequence, it is no exaggeration to say that essentially all databases in use under development today have called Codd's ideas. True, but not entirely true. And that's what associative technology is. Associative technology does not fall under Dr. Codd's work. It is outside the scope of his work, which is why it has had such a difficult time penetrating the marketplace over the last few decades. Everyone has been comfortable with relational theory. So whenever anyone uses an ATM, a purchase, or any kind, anything that you do in the world today is related to a database. That's very important to remember. So this is the end result of this man's work. He created essentially a mathematical algorithm, algebraic equation, that defined what each form of normalization brought to the table. As you'll see in the first through 6 normal forms. The first form is essentially a text file. The second, something like Excel or MongoDB or Raven. And then, of course, the third normal form. Now, the third normal form relates to SQL Server, NoSQL, Hadoop, Cassandra, and pretty much any other system that exists today lives in the third normal form. Now, you will notice that there is a fourth that was defined, there is a fifth that was defined, and a sixth that was defined. Now, what's important here is to understand the graph on the right. The third normal form falls somewhere in the middle of that graph, okay, from a visual perspective. So as you can see, there's plenty of room for improvement. But given that the economics, and this is where capitalism gets in the way of science. Capitalism found a way, and not that I'm a capitalist, so please don't read that the wrong way. It's just that the economics of the situation, they solved their problem in 1971. He gave them the third normal form, which was cheap, easy to use, easy to learn, and it solved the business problem of the day. 50 years on, no one has thought to move and look at solving the problems of today. Now, there's an interesting axiom to that, is that associative technology predates this form of data normalization. And I'll show you that as well. So now, what this graph on the right demonstrates to you is that efficiency is the driving force in all business, but it's also the driving force in all technology. It's what matters. Everything else is secondary, because by more efficiency, you produce more money and you do it in less time.
Is everybody else hearing?
Everybody should be. I'm muting everyone. All right, let me move forward. So, given the form of databases that we have today, these are different types of databases. Okay, just to give you a concept of how many there are. Now, each one of these are types, mind you. So under SQL, you will find at least 100 different products. Under Hadoop, you'll find at least another 100. Under centralized databases, you'll find another 10 or 20. The concept is there are potentially up to 1,000 different types of databases. But the interesting part is that foundationally, they still live in the third normal form. They haven't changed. So as Steve Jobs used to say, I want to make something great. I don't want to make something that is fractionally more impressive. I want to make something that's 10 times, 1,000 times better. Well, in this case, for the last 40 years, we have really done nothing but fractional improvements. There's been no great advance in database technology. Coupling this are the query languages. Now, the query languages, in and of themselves, there's at least 100 of them. Can you imagine learning SQL, which is dramatically difficult in its own right, then GraphQL, LDAP, jQuery, Gremlin? Each of these have their own science and their own technology, their own methodology attached to it. And 100 more. So you can understand why business is aggravated with the IT community. So now we're going to move into association and what that represents. This is the universe as we know it. We live in a three-dimensional space. As you can argue, physics can argue with me later over how many dimensions there are. But right now, what is visible to us is we have left, right, front, back, up, and down. That creates a three-dimensional world that we visually and acutely are aware of. And we function this way. This is our galaxy, the Milky Way, and this is where we exist in that galaxy. Trying to plot our location on an Excel spreadsheet is not going to work. Ever. If you need to go to find your other end at the other end of the galaxy, you've got millions and billions of miles up and down to deal with as well. So essentially, the world and the universe that we know operates this way. It doesn't operate on a spreadsheet on the right. It operates this way. John is simply an element in space with an address, and there is an address for him that is defined by the points. And then we create, and the way association works is simply create one connection to the other bidirectionally, and now we have John Smith. If we want to add a social security number, he's again another association, but you'll notice that the association goes all three ways. Now, if we want to add his middle name, James, we can do that too. If we add his date of birth, we can plug that in too. And we can continue doing this ad infinitum, literally this many times. It's very important to understand that. So the origins of associative technology are essentially the United States Air Force back in 1963. Let me see if I can actually show you that document. This is actually the document going back to 1964. Here's a publication, as you'll see at the bottom, submitted to the U.S. Air Force. Then again in 1967. Okay, this is the Navy project, REMAD. As you can see, again, all designed around associative technology. And again, the interesting thing that these gentlemen all did, these papers reflect the attempt at creating an associative memory chip, not software, All of these projects, with the exception of the Navy project, were designed to create a processor that was associative. So they, out of metal, they tried to create the human brain. Not a brilliant idea when you think about it. So how does the human brain actually work? Well, this is courtesy of UC Berkeley. This is actually how everyone's brain on this planet works, including animals. All mammals basically work the same way. Strangely enough, reptilians do not. But mammals work this way. So you'll see that there are clusters of information that are essentially associated with one another. You have the top, you'll see the yellow area, which is mammals. You'll see an area below that, which is person, and then a movement verb on the left. But you'll see that the yellow basically is double the size of the people. Now, statistically speaking, this gentleman or person or female, whoever it is, statistically speaking, probably works with animals, either a zookeeper, a veterinarian, something of that nature. Because again, everything else is pretty much the same. The location of the city, structure, vehicle, movement, verb, everything's pretty much equal with the exception of mammal. So it would be a good guess. Not a guarantee, but a good guess. But again, if I wanted to connect mammal to vehicle, it would simply be a dendrite or a connector and association. Associative management operates pretty much the same way. So as you can see, there's a yellow area, which could be your mammals, and a green, which could be your people, and orange, which could be your vehicle, or whatever. But by definition, associative nature removes the concept of tables. It removes the concept of a query language. It removes the concept of data duplication. It removes the concept of white space. It removes the concept of orphan records. It's not because it's not done on purpose. The very nature of the architecture lends itself to removing this because they are redundant. They're not necessary. They don't fit. It's like putting a square peg in a round hole. The other aspect is that it is 100% ACID compliant. Now, the reason SQL Server, for all of you who do not know, the reason SQL Server is such a powerful and ubiquitous tool is because it is ACID compliant. Now, ACID compliant is essentially a measurement of the ability to create transactions and validate and verify those transactions. SQL Server is at around 99.98, 94, somewhere in between there. It isn't 100%. Associative by technology, by definition, is 100%. The accuracy, therefore, is also 100%. Now, the reason is, going back here a little bit, I am in this part of the universe. I am nowhere else. And the data acts exactly the same way. So there is no second location to go find stuff. It's here. So just to give you an idea of mechanically how it all works, I'm going to walk you through a very simple process. If I gave you the letter I, what does it mean? Absolutely nothing. It's a character, I. It could have a value of meaning myself if you're English, but in Chinese it will mean nothing. So again, it depends on the context. But it does exist, and that's the important factor. The fact that what it is irrelevant. The fact that it does exist is what matters, and that it exists at a specific location in space. The second, if I did this, I have three other elements, three other words, three other data objects. They each have their own address. Your brain has software in it that does this automatically, if you're English, or speaking American, English American, as to say. You're creating an association between the words, which in turn create a record. Now, Atomic DB as a product does this exactly. Essentially creates a record of the indices of the words, as opposed to storing the words. Now, the words are stored, but they're at a specific location, so I don't have to go look for them anymore. I know where they are. How I associate them is what matters. So now I want to change the word from I love the Yankees to I hate the Yankees. All I do is change the pointer. That's my insert, that's my delete, that's my modify and get rid of. And did I get rid of this? I didn't get rid of it. It still exists. It's still in memory. It's still at its location. I just am not using it anymore. So how does this mean in a more practical term? In a more practical term, I have an example of a record set over here. which has duplicates, and we deduplicate that on a columnar basis. On a columnar basis, all of a sudden, we now, well, how do you retain your records? You simply change and add the pointers. So you'll see Susan points to Smith, points to teacher, and points to 2001, and also as a middle name or a last name, John. But she's also using Jones, Robert, 1991, and Brittany can be used as Smith and Chef, 1998. So we control the indexes. The data, as I said, is a very small area. Now, mechanically, how this particular solution that we have at present works is essentially you're taking a traditional record set, you're moving ahead, and you're creating associative objects for each column. Okay? You're deduplicating each of those columns, and then simply recreating the indices representing these records. Now you'll notice in the first record over here that I have a value of 114879196. But there's a value of 23 associated, 32 and 41. So through 23 will bring us to 3, 32 will bring us to Brown, and 41 will bring us to the first invoice. But the reverse also exists. You'll see that I have 11, 22, 3, and 24, all associated in reverse. So essentially, they're auto-assimilated unique values, and they're cross-referenced, creating indices which are multi-layered indices. So it's not storing into an Excel spreadsheet, if you will. Now, data models. This is the world that we live in. Okay? Everything that you do, every time a businessman says, I want to build an application, this is what needs to be done. And whether you're using SQL, whether you're using Hadoop, whether you're using, it doesn't matter. This is what you need to do. Everything is around these kind of indices that connect to other indices, et cetera, et cetera. This is what data normalization is all about. Now, the problem stems from a huge issue. This is the cube that you see on the left is what's known as a traditional data warehouse. So each database there is essentially a set of three-dimensional cubes. Or it could be one cube, and these are your data elements. So let's assume the green is the resource, the blue is the staff, the orange and red could be the tune. So these are 8 separate databases. Now, trying to extract data from all 8 into this cube is what the people in the world have been trying to do for the last 25 years with very little to no success. 90% of data warehouse projects fail to meet their requirements, and 50% fail outright. As opposed to an associative model. Now, keep in mind, this is exactly the same. These are exactly the same tables, exactly the same databases. These are 8 separate databases. Now, we took this data from a project we're doing in Canada. So this is true. This is actually real life. This is 8 separate data sources, and instead we combine them into a single model. You'll see connects to, case number is the primary element, and the item number is what connects to others' databases. And we're able now to create a single model. And from this, we can extrapolate whatever kind of information that we desire from any kind of tool, any kind of a dashboard. Now, I added the stars of Orion over here to purposely demonstrate to you that the points in the sky are the stars. Those are your data elements. And they created a picture around this. If you decide to use those stars to create a different picture, you're still going to use the same stars. Think of them as John, Jim, Joe, and Jerry, and address and phone number, etc. You just simply create a new set of records. So this is an example of a project that I did a couple of years ago, working with a friend of mine for the home mortgage mess. So we actually went in and deciphered the entire mortgage banking industry in the United States. This is what it looks like, which is really hysterical when you consider that the mortgage, the person actually signing the mortgage is the 2, 3, or 4 blue items at the bottom over here. The rest of this is the banking system. to support that signature, which I find hysterical. Nonetheless, we're able to move and create a database out of this in a matter of minutes, which I will demonstrate for you. If you had attempted to do this in SQL Server, I promise you most of you will have grandchildren before you get done. So the associative model, by definition, is unlimited complexity. You can create a hub and a spoke. This is a collection of data, a collection of data. Each of these is a collection of data. But as you can see, you have a central spoke, a central hub, and you can have spokes, which they in turn can have. Over here, it's a distributed model where there's a central spoke at this one, but it's a different type of hub. It's a different type of spoke model. Each can have an additional spoke. So moving forward, how do we address and access this information? Okay. Under normal circumstances, we would deal with SQL Server, and we would deal with a query language, as you saw before. There are hundreds of them. But the concept is, imagine having to go through billions of records, and then you're writing a question, and you have to search those billions of records in order to achieve the result. So you have a serial thing where you have to go through all billion records and find the comparison that matches your criteria. Well, in the Atomic DB world, we created an API that basically has its login, the get instruction, which is basically the add instruction, import instruction, associate instruction, and modify instruction. This replaces the entire API of every query language on the planet. You'll see that we're working with a model, concept, and an item. Model, concept, item. So the parameters are the same, with the exception of when we're dealing with associate, in which case we're taking two items and we associate those two items. So this allows you the functionality without a massive learning curve. People can learn this in 2 weeks. Really. We took it a step further. We built an interactive online API. So basically, we took all of these instructions and we created this online interactive API. Not only the code that you need to write, the usage, but we're actually going to put the sample and then an actual interactive. You'll be able to plug in the item that you want and run it, and it will return your value so that you don't have to worry about whether you're getting the right information or not. And the thing is, it's entirely based on JavaScript and jQuery, and JSON is your return object, which is an industry standard. Those three are industry standards, and they work, and they're the most scalable from what I've been able to determine over my own career. These three items are far more scalable technology out there. Java doesn't even compete with JavaScript. It's like 100 times slower. jQuery is even faster than JavaScript. So, and JSON obviously is simply a structured return like an XML, but with less of the headache. So now we're moving into the efficiency area. Okay. Now efficiency, and these are some of the basic metrics. So consider a record with 50 columns. And we're talking about a very simple system over here. One processor, 12 gigs of RAM, 7,200 RPM, 500 gig drive. Very straightforward. A record with 50 columns of data represents something like 2,500 triples. Now, this is how databases are measured, by the speed at which they handle triples. We assimilate these records at 50 columns of data, assembling 1 million records in less than 10 minutes. Best case is 3. But we do this in a bidirectional manner. So it's not simply an import and a write and walk away. We've created all of these, so we do about 5 times the work that a SQL Server would do. Okay, and you'll see why. So the equivalent is basically 2.5 billion triples. So we do the same work at 1% of the time necessary. That equates to 4.16 million triples per second, to give you an idea. And that's not optimized yet. Once I finish optimizing next year, that number will go up many dimensions. To produce a functional equivalent in less than 10 minutes, operating sustained throughput of 70,000 composite atomic transactions per second. All right, I've tested it to 70,000 on the existing system. The world record, as of yesterday, the world record is 60,000. And that's on an Oracle 10G system with 4 processors, 256 gigs of RAM, and SSD drives. They got the 60,000. I'm doing this on a laptop. Okay, very big difference. Now we're going to go over a very basic comparison over here of associative versus relational versus NoSQL. All the companies in the world, let's assume we represent all the companies in the world. We get about 100,000 companies. All right, assuming that they have 10 databases each, which is a very small figure. You're talking about 1 million databases. And assuming each of those databases have only 10 tables in them, you're talking about 10 million tables. And then 10 queries per table. You're talking about 100 million queries. Okay, as opposed to one system will handle one for each organization, only one atomic system required, and only 5 universal filters will replace these 100 million queries and these tables. Each atomic DB filter is compatible with every other information store by definition. Every item in atomic DB information store can be referenced and be referenced by an item in its own and other atomic DBs. So I can basically create 5 atomic DBs and have them interact as a single unit. Or I can create 1 million of them and have them act as a single unit. Consider it the ultimate peer-to-peer network. That is what we're building. It already exists. It simply is a matter of exercising it. Multi-store mapping is inherent. So in other words, I can go out and grab 100 databases, drag the data in, and not worry about ETL. ELT, I should say. Exchange transformation language. And there are very few to little IT professionals required to run a query on Atomic DB, and you'll see why. Again, going back to this is what you need to learn. And we've turned this into a click job, into a click situation where just add the stuff you want and go get it. You don't have to deal with it. So what does that mean from a business perspective? We have a SQL data warehouse, or could be a Hadoop data warehouse, could be a SQL database, could be a mainframe, could be a file system, and could be a programmable object. In the medical community, this is a very important thing, because it uses a thing like a product like Epic uses a thing called cache, which is an object, programmable object essentially, and very, very difficult to deal with in terms of extracting information. We can. Furthermore, we can write back to the existing system because everything is on a one-to-one basis. So if I extracted data from SQL, I can write back data to SQL and vice versa. So now we're going to discuss the Atomic Virtual Cloud. What does that allow us to do? All right. Basically, the way the world works today, all applications are third-party related. Everything in the world, you have a device, you connect to the internet, that device then over the internet connects to a server, that server then connects to your destination. Essentially creating a central control point, but also a central monitoring point, a central censoring point, and as we can see with social media today, it's becoming a serious, serious problem. Too few people control access to information to too many. One of the solutions that we're looking at is the ability for the applications, instead of discussing with the central server, will discuss with Atomic DB, and Atomic DB will replicate that data to the destination directly. So essentially creating a virtual cloud. So unless you're a real human being, you're not connecting to the cloud. No robot devices, no system calls, system accounts, no. You have to be logged in as a human being in order to access as a node on the cloud. And the data that you're only able to see is the data that you create yourself. And unless somebody grants you permission to see their data. Now, all of this is factorially encrypted. All right, we have keys that are larger than 4 billion. No, even a quantum computer would take decades to break. And on top of that, we alter the encryption every 30 days automatically. So it's not something that's going to be broken anytime soon. But the concept is, you can see here, whether it's an email application, a database application, or social media, or CRM, the communication occurs from device to device on a peer-to-peer basis. There's no third party. Now, there can be a third party. There is no question. A third party sometimes is required for third-party transactions. That can be easily included as well. Cell phone population. This is as of 2016, I believe. So we have basically 7.3 billion people on this planet. 7 billion of them have cell phones. So I think that the global network is pretty much in place. So that's why this market is the most important, because this allows for communication from people to people without third-party interference. The business impact. This is a critical issue on the financial side, where efficiency is extremely important. These are just U.S. corporate profits the last few years, all right? Roughly about $6 trillion a year. That's the profits that all corporations in the United States have declared. Why is this important? Because our friend over here, and I don't know how many of you have had a boss like this at one point or another in your life, but I have, would be yelling at me, "There's too many databases. Why can't you fix this? Lack of information in a timely manner. Why didn't you tell me?" As an example, we had a deal with a few years ago with an oil company in Texas. They were selling a refinery. The CEO asked the CIO, "Can you identify the value of that refinery for me so I know what I'm selling it for?" CIO came back 6 months later and specified that it was worth some 500 and something million, I remember. And the CEO says, "Oh, good, then it didn't lose any money." He had sold it 4 months earlier on a guess, because he didn't have the information necessary to make a decision. He just went, if I lost money and got money, it was ridiculous to do business that way. Second part is the incorrect information. We know he entered data from multiple locations, and that information is never the same. First name is spelled wrong, last name is spelled wrong, the wrong date of birth, yeah, and the list goes on and on. What this really amounts to, the top three, what they amount to is a loss of control of the business over time. If you're running a print shop, that's not a problem. But if you're running GE and you have 300 divisions, it's a problem. Or if you're running Chase Bank, anyone who's worked with Chase Bank will tell you flat out that left hand has no idea what the right hand is doing, let alone the left foot or the right foot. They don't even know that they exist. And if you ask them today, one of the examples a friend of mine gave me was, if Larry Ellison asked Chase Bank how much he was worth, Chase Bank couldn't tell him. His money is distributed in like 200 divisions. They could not tell him how much money he has. They have no mechanism. Now, people talk about storage dropping in cost, but the fact is, as fast as storage is dropping, data is increasing exponentially. Storage is only doubling. So the curve is not in the benefit of the business. Lack of enterprise reporting, we talked a little bit about. Lack of knowledge and support capabilities. Now, it's all well and good that you hire an expert to come in and build a system for you. And he does a great job, and everything's up and working and running. He goes home. Your guy has to take over, and your guy doesn't have his qualifications. Worse, your guy leaves, and you have to find somebody that has his qualifications. And he decides he doesn't like the system and decides to change everything. You've got a mess on your hands. This has happened more times than you can count. Overly complex systems, absolutely. Anyone who's worked with PeopleSoft or a couple of other complicated programs I worked with in the past will tell you that it's a nightmare. It's a true nightmare. So associative management, because of its flexibility, because of its simplicity, allows for performance increases 1,000 times faster than SQL, no support staff, reduced disk space, because again, we're only storing the data once. We don't have to store it twice. We have easy data analysis because we can extract real values in real time at 100% accuracy. The reduction in development cost, by definition, as you can see, there's only 6 instructions. And even in the web API, there's only about 60. Not a very big learning curve. And of course, you get your answers immediately from our interactive ability. Aggregating data in from heterogeneous systems is now simple, where the data warehouse problem has been around our neck forever. Now, the security model is DoD verified. That's, again, Navy, Air Force. They've done their job in the requirements there, and we actually exceed their requirements. So all of these add up to what I call dynamic business processing. So the merger and acquisition or the dispersal of existing companies is easily done now from a data perspective, which has really been the hardest part. So you have a multi-source data type. You can do your data mapping into whatever formats that you choose or from, and you can then apply whatever business situations that you wish to do and get your results. It's very straightforward. Now, the economics of the situation, which is rather critical. In the world today, we have over 500,000 data centers. Quite literally, you can check for yourselves. Global revenue, roughly around $5 trillion in these data centers. That's, by the way, this is outside of the 3.4 IT costs, okay? Or part of, certain part of it and certain part not. Now, the interesting part, and this is on a grand scale, a third of all data center expenses is power, electricity. Any data center you go to, that's their highest cost item. Their second being, of course, internet access. But their largest cost, far and away, is the energy cost. By simply looking at the physical cost at $1.5, operational, etc., actual data storage requirements represent 70% of all those 500,000 data centers. So 70% of all resources attached to a data center is related to storing data. Not information, mind you, data. And of course, the security overhead represents another 23%. On the application side, Gartner estimates 4.1 trillion will go into IT spend. Okay, apps will lead the charge. Software is the most of the big changes in technology are taking place. Now, here's the fun part. 52% on average of every application developed today to spend on programmers is writing SQL queries for about $750 billion a year. That's insane. Just to write SQL queries. What does that mean in terms of the green world? Well, if we reduce the storage requirements from 70% to 35%, that saves 750 billion barrels of oil, roughly translated. Or, I'm sorry, 15 billion barrels of oil with $750 billion. Okay, global production is only 35. So you're reducing oil requirements globally by 40%, simply by changing the science that you're using to process data. You're reducing overhead labor by 50%. You're reducing physical facility requirements by 50%, construction costs. So again, not necessary to build a 20 million floor data center when 2 will do. And this, of course, also plays into the cybercrime costs of projects to reach $2 trillion. I mean, this is a quote literally from the CEO of IBM. It's not a crime wave. It's an epidemic. Remember, the solutions that we have on the market today are 50 years old. They're not new. The architecture is 50 years old, not 2. I threw the Bitcoin thing in here for a reason. I've been involved with the Bitcoin and the blockchain solution for some, probably 5-6 years now. When I heard about it, I did an enormous amount of research into it. And unfortunately, the blockchain technology is not sufficient nor up to the task of handling a financial system. Certainly not one on the scale of the planet or even a country. Despite what you see in the newspaper now, it's $4,000 a Bitcoin, and they're expecting it to go to $6,800. I liken it to the tulip frenzy in the 1600s, in a way you could buy a house for a tulip bulb. This is some of the losses that have been incurred in the last few years. It's really quite astonishing. Close to $1.5 billion lost, stolen from these exchanges. And I think that the banks getting involved is going to make that even worse. But that's an opinion. Nonetheless, when you change this into a peer-to-peer solution, it makes stealing impossible. And I'll show you why. Everything that we have today in the world, everything that we use in terms of computer systems is essentially a fixed defense. I put our friend General Patent over there because I love this statement. You can't catch a moving target. But if I know what IP address you are, I know what location you're at, I know where your data point of entry is, I will shut you down. Hence the ransomware world that we are familiar with. They know where you are, and as long as they know where you are, they know what your defenses are, they will breach them or they will make them impossible to use. And that is why they have been getting away with this. What we're discussing here is essentially changing and redefining networking. Because as it stands today, it's really in its infancy, and it is a prototype for what should have been a long time ago. But again, economics dictated otherwise, and the next generation of people did not pursue it or to pursue the change. If you're an owner of a company, irrelevant what company you are, this is what your CIO is presenting to you, or your Chief Information Security, your CISO, is presenting to you. And this, as you'll notice, is your domains of influence for securing your world. Now, forgive me, I'm at this 35 years, and I would cringe at the concept of having to deal with this on a daily basis. But this is what's being sold to you as an industry. This is the solution. You have to fix all these things. Every dot here has to be adjusted every single day. Somebody's got to look at it. Somebody's got to monitor it, yada, yada, yada. And it continues this way. It's ridiculous. Atomic DB itself uses a key sequence. The number of possible keys is factorially up to 4 billion, which means even if you put all the quantum computers on this planet, it would take you decades to break a single index. And it's designed for that purpose. The fact that it's three-dimensional adds we actually created a three-dimensional key, which no common system can actually even begin to penetrate, because they can't handle the third vector. Each index is unique and tied to the installation grid, as well as Atomic DB is the device that Atomic DB is installed on, as well as the biometric ID. So we have 3 points of entry to create the unique ID for the installation of Atomic DB. The object-based architecture prevents indiscriminate access, and this goes back to General Patent. As an example, we call this security by omission. We have an environment which is the equivalent of a database. We have models, which is the equivalent of a table, but considerably more. We have concepts, the equivalent of a field, and of course the actual item of data. These are by reference, so essentially context. Within the environment, of which there can be 4 billion, there are models. Each model can in turn have 4 billion concepts. Each concept can in turn have 4 billion items. That's assuming we use our existing 128-bit key. If we expand to 64 bits, we can dramatically increase this to literally 9 quadrillion. So, and we're evaluating that as we speak. So each value has essentially a key of 0, 0, 0, which in turn gives it a set key item. Okay, so now that's the address of this environment. Now, in real practical terms, I have my database with a value of 1, customer model with a value of 0, first name field with a value of 0, and John, the actual item, the value of 0. So now we go and we do our referral. So within this database, 1 out of 4 billion, I have a table called customer, or a model called customer. It has a value of 0. Same with first name, same with John. That creates an address of 1-000. So now I know that I'm talking about John. I know that I'm talking about first name, and I know that I'm talking about customer, and I know that I'm talking about my database. If I add a second value to John called James, you'll see that it's now 1001. Okay? And the third, 002. So I have a reference in space of wherever I put that data item. Reference. Now we'll move into how we create the association. So if I want to create a separate, I'm sorry, I step back a little bit. From the model customer, I will go into the field name, and I say now I want to put in last name. And again, you'll see that has a different key again. So I can continue doing this 4 billion times. Now, moving back a step, we're at the model customer, where we have first name, last name, 2 values, and I'm going to add Social Security as another value within another field within customer. It will have 2 values, each with their own address. Okay, and now what we've done is created an association. John is associated with Smith as the last name, and his Social Security number is 4545. Now, if we create another one, we're still using John, right? We're using James, I'm sorry, James, and we're using Smith again. And of course, we're using his Social Security number. So as you can see, it creates these records on a numeric basis, but it creates this on a logical basis that we can see. So you'll see I still have the same name Smith, but they're 2 different values, 3 different values, 4 actually. So security by omission means this. The users, profiles, groups, admins, of course, exist. But for a user, must be granted access, or an association has to be created in order for him to actually find the data. If that user does not have an association with these elements, he's not going to find the data. It simply doesn't exist. The logic doesn't exist. That prevents people from indiscriminately looking for data, because their user object cannot access anything that it's not associated with. It's just not there. And as opposed to an Excel spreadsheet where you can hide columns, the data is in the column. Hidden or not, it can be hacked and it can be opened. In our world, the data simply isn't there. If you don't have a pointer to that element, you're not going to find it. So that makes hacking even more difficult. So I've explained to you a little bit about the back door, a little bit about association, but the front door is equally as important. And I've touched on that a little earlier. Biometrics is the only way. There is no other way. User ID and password, second factor authentication, they're negligibly no longer valid. Most of them have been hacked. Many have been significantly abused. And one of the arguments that I always say, security, is there such a thing? Has there ever been such a thing? Since the inception of the computer in the early 1960s, securing the data information it holds has been the Achilles heel of the entire solution of computer science. Okay? This weakness did not escape the scientists, the designers, the engineers of the time, and they did resolve the problem. Associative. They knew back in the 60s when they first built the processor that this was a problem. And they came up with associative technology as a solution for it. Only the economics of the time did not permit the construction of an associative computer. It cost too much money. IBM cost 10 million, an associative processor system would have cost 100 million. So this is where capitalism gets in the way of progress. And our online mobile payment system, which is now becoming the standard around the world. Africa pretty much runs entirely on the mobile system. The United States, it's on the web. Online buying has exceeded retail on the stores for the first time, and that will continue to climb. Now, the recording of data manually may result in an error, and as we all know, basically 35% of all data entered into the system manually is fraught with errors. And that's a very high figure, but it's about 35%. Now, the other issue is no proof of payment made, etc. And of course, the privacy is the biggest issue, the anonymity another, the auditing another. This is all solved by biometrics and association combined. We partner with our partner in Innovate in Israel, and together they've created for us a solution which defies most other biometric solutions, in fact all biometric solutions on the planet. You don't need a username and password anymore. You can have one if you want one, but you don't require one. The multi-factor authentication includes the face, your hand, your voice, facial recognition, your iris, your skin tone, and actually a couple of other things that we don't talk about, and provides a complete single sign-on solution. And it will, of course, integrate with any corporate security system and directory. So your palm print is there. It's really quite amazing. And this all accomplishes itself in 4 seconds, by the way. So again, a client clicks onto Innovate, unique one-time or code will appear on the client's queue. This is just one mechanism. There are 3 others, by the way. The cyber phone captures or the code and begins the biometric verification process. The client repeats the one-time password if necessary. It is recorded by the smartphone. At the same time, front-facing capture captures one or more facial images. That, in turn, allows the data along non-biometric verification are sent to the bank. The bank then does its work, authenticates the client, granted access to that account, and boom, we're off to the races. Bio login is done. Nothing to type, only 10 seconds. The data is encrypted, biometric signature, digital proof, and paper invoices if necessary. So essentially, we can convert any shop to the bank to you in seconds. And we know it's you. There's no getting around it. Because as I said, in the Atomic DB cloud, you cannot be granted access to the cloud unless it's a human being. There are no machine codes that will be allowed into the system. And the phone, as you can see, is the vehicle. Now, this is essentially the business case. As I said, there are 7 billion phones in the world right now. This is how the US households actually pay their bills. It's all going online. It's all going mobile. Paper is down to like 10% as we stand. So how do we apply this to real world solutions? One of the things that we've done is talk to the medical industry. With our partners AMI in Canada, we were able to design and create a solution whereby we used the basics of associative technology and identified 5 or 6 different sources of data using the healthcare as an industry because it's the one that's the most in trouble in the world. And we figured we could do the most impact there. And all countries in the world basically have central payer systems with the exception of the United States. So we started with Canada, and we were able to determine simply by combining the data. You know, we combined the patient data, we combined the doctor's data, we combined the vendor data, we combined the procedure data, we combined the preference cards. And by simply combining that data and extrapolating, we were able to restore $2.2 million into their account. This is only on 3 hospitals and 8 different locations, and only on 5 procedures. Now, most hospitals have upwards of 150 procedures. So when you extrapolate this, for example, Canada has a $250 billion healthcare budget. And when you extrapolate that we could give them back 15 to 20% of that budget, you're talking somewhere in the neighborhood of $30 billion that they can then restore to the healthcare system. It's rather significant. And again, because of the simplicity of the solution, anyone can do it. We've designed it that way. So essentially what it amounts to is Hospital 1, Hospital 2, regardless of what system they're running, whether it's Epic, Cerner, Allscripts, can be extracted into Atomic Information System, Atomic DB. Atomic DB then can turn around and either create business intelligence, which is what we're doing now. We can create management access and write back to the system if necessary. We can incorporate a billing solution and evaluate and audit that. And of course, we're also working on a new flexible EHR record system that would allow interactivity between the doctor, the patient, and the billing system. So this is some of the costs, as I said. We took hospitals and we simply consolidated that data and returned it. And we're able, on Arthropos, we were able to track where the money was being lost, where the money was being made. And we established cost reductions, as you can see, 19%, 10%, 8%, across the board. And those are significant in the healthcare industry, which is screaming even for 1%. This is an example of our data warehouse dashboard. This is our dashboard as of right now. It can be anyone's dashboard for that matter. It doesn't have to be ours. We simply provide the data and you can extrapolate it any way you wish. But as you can see, what was required here was an overall hierarchy, the locations, the countries, locations, the sites, the hospitals, the corporations, and all of the areas aggregated. And you can bidirectionally click on any element and it will return either forwards or backwards to investigate. The future of what we're looking to do and accomplish is essentially a patient-centric healthcare record system. Going back to my cloud, as we discussed, the client would have possession of all his records. The only one able to read or write would be medical professionals, but the records would stay with the client. Now, whether that's on a laptop, portable, or a tablet. And that would allow for unique, anonymous patient ID. And that would allow for automated billing. And it would allow for complete privacy. So what this means in third-party integration is we can take any number of systems at the top, whether it's an accounting system, HR system, inventory, online sales, merchant, combine that into a single source and then provide it to things like Domo, Tableau, ClickView, SAS, or anything other. There's about 100 of them. So it's up to you guys, what you want to work with. We're presently working with Logi Analytics. We're going to start that relationship on September 1st. Because we found them to be the most flexible. And that's our team. Keith, our Chief Operating Officer, Sriyash Kadi, our Chief Technology Officer, Cindy Logden, our VP of Healthcare Services, Ken Rubin, Sales, our partners in Canada, David Howe and Ken Grant. And we have a few others that are being added daily. And that's where we're going to stop this.